The operations on functions are addition, subtraction, multiplication, and division. Let's say you have two functions, f and g. So y sub 1 be equal to f of x, and y sub 2 be equal to g of x. When we say f plus g, well, we mean f of x plus g of x. So you just have to add the expressions defining the functions f and g. Okay. Now f minus g simply means f of x minus g of x. So therefore we just have to subtract the expression defining g of x from the expression defining f of x. Now f times g, just means f of x times g of x. So we just have to multiply the expressions defining f and defining g. So f over g simply means f of x divided by g of x, provided, of course, that g of x is not equal to 0. Say, for example, you're given f of x equals sine squared x and g of x equals cosine squared x. Find, say, A, f plus g, B, f minus g. Okay. C, you can have f times g, and then D, we can have f over g, or maybe we can also have g over f. Okay. So to answer A, so f plus g means f of x plus g of x. So the expression defining f of x is sine squared x. So this is sine squared x. And the expression defining g of x is cosine squared x. Cosine squared x. As you can see, sine squared x plus cosine squared x is an identity. It's actually a Pythagorean identity, which is equal to 1. Can we review on the trigonometric identities that you have already encountered? This is equal to 1. So this is f plus g. Now going on, f minus g. Let me just recall the Pythagorean identity that we have here. So we have to recall the Pythagorean identity. Sine squared x plus cosine squared x equals 1. Alright, just to be clear on that. Alright, so going back to B, f minus g is sine squared x minus cosine squared x. Alright, now again, recall a double angle identity, again from the trigonometric identities. We have cosine 2x equals cosine squared x minus sine squared x. Okay, so but what we have in our f minus g is sine squared x minus cosine squared x. So therefore, if we multiply both sides of this identity by negative 1, then we'll just simply have negative cosine 2x is equal to, so the first term cosine squared x would be positive, and second term would be negative, so would be positive. So cosine squared x would be negative, and then sine squared x would be positive. So sine squared x minus cosine squared x. Alright, so that means to say that f minus g, going back to our solution, so it's exactly equal to this, is equal to negative of cosine 2x. Alright, this is our final answer, simplified. Going to C, f times g. F times g is simply sine squared x times cosine squared x. Now there's a way to simplify this if you would just recall the double angle identity of sine function. That is sine 2x equals to sine x cosine x. Okay, so if we divide both sides of the equation by 2, we'll get 1/2 of sine 2x equals sine x cosine x. Alright, so going back to f times g. F times g is equal to, well, sine squared x is actually sine x times sine x, right? So that's sine x times sine x. And then cosine squared x is cosine x times cosine x. Okay, so that's actually, you know, that multiplication of real numbers is commutative anyway, so we can just write this as sine x times cosine x. Okay, and then another sine x times cosine x. Okay, where sine x cosine x, according to this encircled part, is 1/2 of sine 2x. Okay, and then the other sine x cosine x is again 1/2 sine 2x. So multiplying 1/2 sine 2x by itself will get, well, 1/2 times 1/2 is 1/4. And then sine 2x times itself is sine 2x squared. Okay, so this is f times g. Simplifying in simplified form. Now answering D, f over g is just f of x over g of x, so that would be sine squared x over cosine squared x. Again, recall the identity. This is actually the quotient identity. Tangent x equals sine x over cosine x. But then this is squared, so we have to square tangent x and also the right side of the identity. So going back to f over g is equal to tangent squared x. Okay, we get tangent squared x upon squaring both sides of this identity. Okay, and then finally for letter E, which is quite similar to letter D, g over f this time is g over x over f of x, g of x over f of x, so that's going to give us cosine squared x over sine squared x. Now recalling another quotient identity, cotangent x equals cosine x over sine x. Again, squaring both sides of this equation, then we'll have on the right side cosine squared x over sine squared x, which is exactly this. And so going back to g over f, that's equal to cotangent squared x when simplified. This is our final answer. Now let's take another example. You're given in number 2, f of x equals ln of x squared, and g of x is equal to 5 ln of x. Okay, let us first recall some properties of ln. Properties of ln, which is the natural logarithmic function. Okay, properties of ln. One, that r ln of a, which is actually this. Okay, this is in the form r ln of a, can be written as ln of a to the r. Okay, and also that ln of a plus ln of b, when simplified, can be written as ln of a times b. And then ln of a minus ln of b can be written as ln of a over b when simplified. Okay? And you also have to know that, well, ln of 1 is 0, and then also that ln of e, that number, is equal to 1. These are important. So in this problem, we'll just have to find, so just the f plus g, f minus g, and maybe we can have, no, g minus G minus F. And we can also have F times G and F over G. Okay, so to answer letter A, F plus G is actually F of X times G plus G of X. It's ln of X squared. Okay, plus 5 ln of X. But if we try to look at the first property that I have written on top of the page, the second term can actually be written as ln of X to the fifth. Right? So using the properties, the second property at that, so ln of A plus ln of B, where A here is X squared and B is X to the fifth. So it says in the second property that ln of A plus ln of B can be written as ln of A times B. So that would be X squared times X to the fifth. While X squared times X to the fifth will give us X to the seventh. So this is F plus G. Okay. In letter B, F minus G is F of X minus G of X. So that's ln of X squared minus 5 ln of X. Again, applying the first property in the second term, we'll have ln of X squared minus ln of X to the fifth. And then applying the third property that says ln of A minus ln of B equals ln of A over B, where A again is X squared and B is X to the fifth. So this will give us ln of X squared over X to the fifth. Dividing X squared by X to the fifth, we'll simply have ln of 1 over X cubed. Okay, so copying the base X and then subtracting. So you'll have ln of X, copy the base X, subtracting the exponents 2 minus 5. So that will give you ln of X raised to negative 3, or simply ln of 1 over X cubed without the negative exponent. Okay, now answering letter C, which is G minus F. So we'll just interchange the minuend and subtrahend. That's going to give us 5 ln of X minus ln of X squared, or that's ln of X to the fifth minus ln of X squared, applying the first property again in the first term. That's ln of X to the fifth this time over X squared. This time applying property number 3, okay, for ln of X, ln of A minus ln of B. So the answer is ln of X to the fifth divided by X squared is X cubed. So again, copy the base to divide X to the fifth by X squared, copy the base X, and then subtract the exponents. So this is G minus F. Okay, so for letter D, this doesn't make so much sense. F times G is simply ln of X squared times 5 ln of X. Alright, so we can just write this as 5 ln of X squared times ln of X, or whatever, using the property. So, or you can just write this as ln of X squared times ln of X to the fifth. Okay, it's the same thing. It's also correct. And then for the last one, F over G, it's simply ln of X squared over 5 ln of X. Okay, so the numerator, using property number 1, the numerator now can be written as 2 ln of X, and then the denominator is 5 ln of X. So ln of X over itself is just 1, so therefore F over G is simply equal to 2/5. Alright, that's it. Or wait, you can simplify this in letter D. Maybe you'll ask this question. if you have f times g, let me just rewrite this in another way. Uh, ln of x squared times 5 ln of x. Okay, so this first term can be written, or first factor, that is, can be written as 2 ln of x. Okay, so 5 ln of x. And then we multiply the constants, 2 and 5, we get 10. And then we multiply ln of x by itself, ln of x by itself, just square. Okay, so this can be also, f times g can also be written as 10 times ln of x squared. That's another way to write the answer. Well, it's more simplified, it's shorter in this way. Okay, that's it.